Prologue, the architect of uncertainty. Imagine a box. It is made of steel, reinforced, impenetrable. Inside this box there is no light, no sound, no observer. The contents of the box are simple, yet they constitute the most terrifying arrangement in the history of human thought. There is a tiny amount of radioactive material, so small that in the course of 1 hour, there is exactly a 50% chance that one of its atoms will decay, and an equal 50% chance that it will not. There is a Geiger counter, waiting silently to detect that single, solitary atomic spark. There is a mechanical hammer, poised like the scythe of the Grim Reaper. There is a flask of hydrocyanic acid, a poison so potent that a single breath guarantees the end. And finally there is a cat. We seal the box. We lock the world away. And now we wait. 60 minutes. 3,600 seconds. Inside that steel chamber, a drama of existence is playing out that defies every instinct you possess. According to our common sense, the cat is currently either alive or it is dead. It is one or the other. It cannot be both. That is the law of reality. That is the law of logic. But according to quantum mechanics, the most rigorously tested and successful scientific theory the human race has ever produced, our common sense is wrong. Until we open that box, nature has not decided. The atom has both decayed and not decayed. The hammer has both fallen and stayed raised. And the cat is both dead and alive, simultaneously. You have heard of Schrödinger's cat. You have seen it on t-shirts, in memes, in pop culture references, from the Big Bang Theory to Rick and Morty. It has become the mascot of the weirdness of science. But almost everyone gets the story wrong. They think Erwin Schrödinger created this thought experiment to explain how quantum mechanics works. They think he was teaching us about the magic of the universe. He wasn't. Erwin Schrödinger didn't create the cat to support quantum mechanics. He created it to destroy it. He conjured this zombie cat to demonstrate that the prevailing theory of his time was not just wrong, it was absurd. It was a joke. But the joke was on him. Today, we are going to do something dangerous. We are going to open the box. We will travel back to the smoke-filled rooms of the 1920s, where a civil war in physics threatened to tear our understanding of reality apart. We will read the private letters between Einstein and Schrödinger that birthed this paradox. And we will discover why, nearly a century later, this imaginary cat is the key to the most powerful computers ever built, and perhaps the proof that you are not the only you in existence. So, take a deep breath. Because once we look inside, we can never unsee the truth. Chapter 1. The cracks in the foundation. To understand why a cat can be dead and alive, we have to understand the world before the chaos. For over 200 years, physics was a safe place. It was built on the bedrock of Isaac Newton. It was a world of determinism. If you kicked a ball, and you knew the force of the kick, the weight of the ball, and the resistance of the air, you could predict exactly where it would land. Every single time. The universe was a machine, a clockwork mechanism. If we knew the position and speed of every particle in the universe right now, we could perfectly predict the future and perfectly reconstruct the past. There was no mystery. There was only math. But in the early 20th century, that beautiful clockwork machine began to break. Physicists started looking deeper. Not at balls or planets, but at the fundamental building blocks of matter. Atoms, electrons, photons. And down there in the subatomic realm, the laws of Newton didn't just stop working. They vanished. Imagine throwing a tennis ball at a wall. You expect it to bounce back. But in the quantum world, occasionally, The tennis ball would simply pass through the wall like a ghost. Or it would be in your hand and hitting the wall at the exact same moment. This was quantum mechanics. And it terrified the old guard. The conflict came to a head in October 1927 at the Solvay Conference in Brussels. It is arguably the most intelligent gathering in human history. 17 of the 29 attendees were, or would become, Nobel Prize winners. But beneath the polite smiles and the formal suits, a war was raging. A war for the soul of reality. On one side, the undisputed heavyweight champion of physics, Albert Einstein. Einstein was a realist. He believed in an objective reality. A reality that exists whether we look at it or not. To him, an electron has a place. It has a speed. If we can't measure it, that's our fault, not nature's. God, Einstein famously declared, does not play dice with the universe. On the other side stood Niels Bohr, the Danish physicist with a radical new idea. Bohr, along with his brilliant young protege Werner Heisenberg, proposed something that sounded like madness. They called it the Copenhagen interpretation. They argued that Einstein was asking the wrong questions. They said that at the quantum level, particles do not have fixed properties until they are measured. Before you look at an electron, it is not here or there. It is a wave of probability. It is everywhere that it could be. This is called superposition. And the act of looking, the act of measurement forces that wave to collapse into a single reality. Bohr looked Einstein in the eye and said, "Stop telling God what to do." Bohr was effectively saying, reality does not exist until you observe it. Einstein couldn't accept this. It violated everything he believed in. He felt that if Bohr was right, then science itself, the pursuit of describing the objective world, was dead. He needed an ally. He found one in a man who was equally disgusted by this blurred reality, the Austrian physicist Erwin Schrödinger. Together they began to plot. They needed a weapon, a logical weapon to expose the absurdity of Bohr's ideas. They didn't need a lab. They didn't need equipment. They just needed a cat. Chapter 2. The letter that changed everything. It was 1935. The debate had reached a stalemate. The world was changing. Shadows were lengthening across Europe, but in the world of theoretical physics, the battle was purely intellectual. Erwin Schrödinger sat down to write a letter to Albert Einstein. In this correspondence, they were mocking the Copenhagen interpretation. They were laughing at it. They were looking for a reductio ad absurdum, an argument that disproves a statement by showing it leads to a ridiculous conclusion. Schrödinger wrote one, can even set up quite ridiculous cases. And then, he described the infernal machine. He wrote, a cat is penned up in a steel chamber, along with the following device, which must be secured against direct interference by the cat. He went on to describe the Geiger counter, the radioactive source, and the flask of poison. It is important to note that Schrödinger never actually performed this experiment. No cats were harmed in the making of quantum mechanics. It was a thought experiment, a scenario played out in the mind. His logic was razor sharp. According to Niels Bohr, a quantum system remains in superposition until it is measured. The radioactive atom is a quantum system. Therefore, until the Geiger counter registers a click, the atom is both decayed and stable. But Schrödinger connected that microscopic quantum event to a macroscopic event, the life of a mammal. If the atom is in superposition, the Geiger counter must be in a superposition of clicked and not clicked. The hammer is in a superposition of fallen and raised. The poison is in a superposition of released and contained. And therefore, the cat is in a superposition of dead and alive. Schrödinger looked at this scenario and essentially said, this is nonsense. In his letter, he stated that this situation prevents us from naively accepting as valid a blurred model for representing reality. In itself, it would not embody anything unclear or contradictory. There is a difference between a shaky or out-of-focus photograph and a snapshot of clouds and fog banks. He was arguing that just because we don't know the state of the cat doesn't mean the cat doesn't have a state. The cat knows if it's alive. The flea on the cat knows if it's alive. To say the cat is blurred until a physicist opens the box was, to Schrödinger, the height of intellectual arrogance. He thought he had won. He thought he had cornered Bohr and Heisenberg with a scenario so ludicrous that they would be forced to admit their theory was incomplete. But he underestimated his opponents. And he underestimated the universe. Because when Niels Bohr heard about the cat, he didn't back down. He didn't say, "Oh, you're right, Erwin, that is silly." No. Bohr looked at the box and effectively said, "Yes. The cat is both dead and alive." So what? Chapter 3. The Ghost in the Machine. So, Schrödinger thought the idea of a blurred cat was a joke. But the universe, it seems, does not understand sarcasm. To understand why the cat is actually both dead and alive, we have to leave the box for a moment and look at the experiment that breaks reality, the double-slit experiment. Imagine you have a wall with 2 vertical slits cut into it. Behind that wall is a screen. Now, imagine you have a machine gun firing bullets at the wall. Some bullets get blocked, some pass through the slits. On the back screen, you would expect to see 2 strips of bullet marks. Left slit, right slit. Simple. Now replace the bullets with electrons, tiny particles of matter. Scientists fired them one by one. Click, click, click. At first, they looked like particles. But as the pattern built up on the back screen, something impossible happened. They didn't form 2 bands. They formed a series of alternating bright and dark stripes. This is called an interference pattern. It is the kind of pattern you get when waves of water crash into each other. It means the electron didn't go through the left slit. It didn't go through the right slit. Mathematically, the single electron went through both slits at the same time, interfered with itself, and landed on the screen. This is the heart of the nightmare. Matter, the stuff you and I are made of, behaves like a wave when no one is looking. In quantum mechanics, we describe this with something called the wave function, represented by the Greek letter psi psi. The wave function is not a physical object. You can't touch it. It is a mathematical list of possibilities. It tells us the probability of finding the electron here, or there, or anywhere else. Before you measure it, the electron is not in a specific place. It is a ghost. It exists in a superposition of all possible locations. Now, bring this back to our cat. Schrödinger's cat is made of atoms. Those atoms are made of electrons and protons. If the subatomic particles are waves of probability, then the collection of those particles, the cat, must also be described by a wave function. Schrödinger's equation, the formula that won him the Nobel Prize, doesn't stop working just because the object gets bigger. It just gets more complex. So, in the darkness of that steel box, the cat loses its solidity. It becomes a wave of dead state and a wave of alive state, rippling through the darkness, overlapping, interfering with each other. It is not that we don't know if the cat is alive. It is that the cat has no defined existence. But then you open the box, you look, and suddenly the wave vanishes. The interference stops. The electron snaps into one position. The cat snaps into one state, alive or dead. This is called the collapse of the wave function, and it leads to the single most disturbing question in the history of science: what is special about you? Why does nature behave like a wave when it's alone, but behave like a particle when you look at it? Do your eyes have superpowers? Does your consciousness force the universe to make up its mind? For decades, the Copenhagen interpretation, the view of Niels Bohr, simply said, "Don't ask." It said the measurement causes the collapse. End of story. But there was another man who looked at the math and saw something else. Something that didn't involve a collapse. Something that involved everything else. Chapter 4. Escaping the Box, the Many Worlds. The year is 1957. A graduate student named Hugh Everett III is drinking sherry with his friends at Princeton. He is looking at Schrödinger's equation, and he asks a question that nobody else dared to ask. What if the wave function never collapses? What if, when you open the box, you don't force the universe to choose? Everett proposed that the math describes a reality that is much, much larger than we can perceive. He suggested that when you open the box, the universe splits. Listen to this carefully, because it sounds like science fiction, but it is legitimate physics. In this view, known as the many worlds interpretation, there is no collapse. The wave function continues to evolve. When you look at the cat, you become part of the system. You become entangled with the cat. At that moment, reality branches like a tree. In one branch of the universe, you see a live cat. You feel relief. You pick it up. You go on with your day. In another branch, exactly as real as the first one, you see a dead cat. You feel grief. You bury it. Both outcomes happen. Both versions of you exist. But because the branches have separated, they can no longer communicate with each other. To the you with the live cat, the other world is gone. But it is not gone. It is just elsewhere. This transforms Schrödinger's ridiculous joke into a vertiginous reality. It means that every time a quantum event has more than one, which happens trillions of times a second inside your own body, the universe splits. There are infinite versions of you. There is a version where you didn't click on this video. There is a version where you became an astronaut. There is a version where you died 5 minutes ago. And there is a version where humanity never existed at all. Schrödinger created the cat to mock the idea of a blurred reality. But if Hugh Everett is right, the reality is far stranger than a blur. It is an infinite library of everything that could possibly happen. Now, I know what you're thinking. This is insane. If the cat is a wave, why have I never seen a wavy cat? Why do I never see a table that is in two places at once? The answer lies in a concept called decoherence. You see, the cat isn't just floating in a void. It is surrounded by air molecules. It is sitting on metal. It is being hit by photons of heat. In quantum mechanics, observation doesn't require a human eye. It just requires interaction. The air molecules inside the box are constantly bouncing off the cat. They are measuring where the cat is. They are interacting with its atoms. This constant bombardment leaks information about the cat's state into the environment. This interaction destroys the delicate quantum superposition almost instantly. The universe is constantly looking at itself. So, the reason you never see a zombie cat hovering between life and death is that the environment has already opened the box for you, billionths of a second before you even looked. The cat was forced to choose a side long before you unlocked the lid, but this doesn't solve the paradox. It just hides it. Because if you could isolate the cat perfectly in a vacuum, at absolute zero temperature, shielded from every single photon, the math says the superposition would remain. The zombie cat would be real. And guess what? We have actually done it. We haven't done it with cats yet, but we have done it with molecules. We have created Schrödinger's kittens. We have placed clusters of atoms in states where they are vibrating and not vibrating at the same time. We have proven that Schrödinger was right, even if he didn't want to be. The boundary between the microscopic quantum world and our macroscopic human world is blurring. And as we learn to control this boundary, we are unlocking powers that seem like magic. Chapter 5: The Zombie Cat That Runs the Future. For decades, Schrödinger's cat was just a ghost story. It was a philosophical chew toy for physicists to argue about over coffee. But in the 21st century, the cat woke up, and it went to work. Today, the very paradox that Schrödinger mocked the idea of something being in two states at once is the fuel for the most powerful machines humanity has ever dared to build: quantum computers. To understand why this is terrifyingly powerful, look at the device you are using to hear my voice right now. Your phone, your laptop, the server hosting this video, they all run on bits. A bit is like a tiny switch. It is either OFF0 or it is on 1. It is like a normal cat. Alive or dead, everything you see on the internet is just billions of these switches flipping back and forth. But a quantum computer doesn't use bits. It uses qubits. And a qubit is the cat. Because of the principle of superposition, a qubit doesn't have to choose between 0 and 1. It can be 0 and 1 at the exact same time. Imagine you are in a maze. A classical computer is like a single mouse running through the maze. It tries one path, hits a wall, turns back, tries another. It is fast, but it does things one by one. A quantum computer is like a flood. It doesn't run down one path. It fills every single corridor of the maze simultaneously. It finds the exit not by trial and error, but by being everywhere at once. This is the power of the zombie cat. Tech giants like Google, IBM, and nations around the world are currently in an arms race to build these machines. Why? Because a stable quantum computer could solve problems that would take a traditional supercomputer 10,000 years to calculate. It could model complex molecules to cure cancer. It could design battery materials we can't even imagine. But there is a dark side. The encryption that protects your bank account, your emails, and national secrets is based on math problems that are hard for classical computers to solve. But for a machine that can exist in a billion states at once, that math is easy. When the cat truly wakes up, privacy as we know it might end. Schrödinger created his thought experiment to show that quantum mechanics was uselessly absurd. Irony is a cruel mistress, because that useless absurdity is about to become the most valuable resource on Earth. Conclusion: the cat is out of the bag. Erwin Schrödinger died in 1961. He went to his grave still suspicious of the quantum world he helped discover. He famously said, "I don't like it, and I'm sorry I ever had anything to do with it." He tried to use a cat to show us the limits of our understanding. He wanted to draw a line in the sand and say, "This far and no further." Reality must make sense. But the universe refused to cooperate. Instead of showing us the limits of nonsense, he inadvertently revealed the limitlessness of reality. He showed us that the solid, dependable world we think we live in is just a facade. Zoom in close enough, and the certainty dissolves. The furniture, the ground beneath your feet, the hand holding your mouse, it's all just a shimmering ocean of probabilities, waiting for an observer to force it into existence. So, does the cat live or die? Perhaps that is the wrong question. The question isn't about the cat. It's about you. The experiment tells us that we are not just passive spectators in the universe. We are participants. We are the authors of reality. By looking, by measuring, by questioning, we are the ones to pull the world out of the chaos. The box is open. The cat is out, and reality will never look the same again. This has been a deep dive into the archives of quantum files. Now, I have a question for you to answer in the comments below. It's a choice that defines how you see the universe. Do you side with Niels Bohr and believe the cat has no state until you look? Or do you side with Hugh Everett and believe that somewhere in the multiverse, there is a version of you who found the cat alive and another who found it dead? Let the debate begin. If you want to explore more glitches in the matrix and paradoxes that break physics, make sure you are subscribed to Quantum Files. Right now, the button below is in a superposition of being clicked and not clicked. Collapse the wave function. Hit subscribe, and I will see you in the next timeline.